Breaking the wall to water security. How consumers, politics, business and investors can advance sustainable, fair and efficient water use. Arjen Hoekstra, University of Twente, Enschede.
When the Berlin Wall came down, I was remembering my Eastern Bloc bike adventures and thinking about birds in East Berlin.
Some people say water is the next carbon. The World Economic Forum has made a list of risks to the global economy. And water is the number one, surprising to many. So water stands even beyond the risk of diseases, weapons of mass destruction, interstate conflict, or even climate change. So breaking the wall to water security is one of the greatest challenges to human being. Now, water is a huge risk to the global economy, but it's also the reverse. Of course, the water crisis we are facing is caused by the structure of the global economy, by the production and consumption patterns and the patterns of trade, and the way we organize our economy. So we have intensively studied water crisis, global water crisis, over the past 10 years, and found out that there are 4 important issues that we should be concerned with. First of all, sustainability of the water use. Second, the efficiency of the water use. Third, equitable water sharing. And finally, the security of the water supply. Let me start with where we should start, and this is our consumption pattern. And as an example, I take Germany. So what you see here is the water footprint of the average German consumer, about 3,900 liters a day. And in the top, you see a very small piece of the pie, which is 2% of your water footprint is related to domestic water supply. So only 2% of your water footprint relates to water use at home. 10% of your water footprint relates to the industrial products you consume, and 88% of the water footprint relates to the consumption of agricultural products, mainly food, of course, whereby 45% of the water footprint relates to the consumption of animal products, and more than a quarter to the consumption of meat. Now, if we talk about the water footprint, we talk about water consumption and water pollution. There are 3 components. The blue water footprint relates to the consumption of groundwater and surface water, and then we refer to the net abstraction, because water use in itself is not a problem. If you take it and you put it back and it's clean, no problem. But what we measure in the water footprint is the net consumption. So you cannot reuse that water. The blue water footprint measures the ground and surface water being consumed, and the green water footprint measures the rainwater being consumed, not being able to use it for another purpose, and the gray water footprint measures the amount of water being polluted. Now, the water footprint of consumers is not locally, it's not at home, it's outside your home, but it's also not in your own country often, it's largely outside the country as well. In Germany, for instance, 69% of the water footprint of the consumption is not in Germany, but it lies outside Germany. You see here the color, the intensity of the color shows the amount of water use in different places on Earth where commodities are being produced with water locally that are being exported to Germany and consumed in Germany. And we know this for every country in the world, how that pattern is. And we know what is behind all those pixels, behind this water use. For instance, strawberries, olives in southern Spain contributing to the drying of the Cota Doñana National Park. For instance, soybean from Brazil contributing to the deforestation. For instance, roses from Kenya competing with other water uses locally, polluting the water of Lake Naivasha. Or cotton, for instance, from Turkey, Pakistan, India, Central Asia. You already saw this picture earlier today, the drying of the Aral Sea. And why that happens is because of the water use in the region from 2 rivers, the Amu Darya, the Ser Darya, for irrigating cotton. And the rivers don't end up in the sea anymore. So the sea is slowly disappearing, evaporating. And this is one of the biggest environmental disasters in history, man-made. And why? For cotton. And you can see it from the satellite images. In a very fast time, we are able to transform the Earth just for an ordinary purpose like cotton cloth. And this is not the only place. The water footprint of humanity is not sustainable, and you see it in this graph. The green areas are okay. Those areas, the water footprint, the blue water footprint, is below the maximum sustainable level. But in the yellow and the red areas, the water footprint locally is beyond the maximum sustainable level, beyond the amount of water that is sustainably available. This translates into declining groundwater levels, empty rivers during part of the year, drying deltas, and disappearing lakes. For instance, even the declining groundwater levels, we can measure it through the reduced gravity locally. We can see so many places where water is being depleted. Currently, this has been an incredible amount of work to understand actually why there is this water scarcity. We know per pixel what is the amount of water available and what is the amount of water used, precisely for which purposes, and where the water-intensive commodities are being exported to. The future I envisage is one in which we can real-time monitor the amount of water available and also the amount of water being used by farmers, industries, etc., just from satellite images through remote sensing. This will help us to respond more quickly to droughts and increasing scarcity. But I think even more important is the societal breakthrough which we need, which means that we need to formulate water footprint caps per river basin. Set a maximum to the amount of water we can consume. Just like something like the carbon footprint caps on a global level, we need water footprint caps at a river basin level. Water use is not sustainable, but also not efficient. You can see it in this map, which shows the water footprint of wheat in terms of cubic meter per ton, or liter per kilogram. And the green areas are the places where the water footprint is relatively low. The red areas, water use is very inefficient. So we have a very big water footprint per kilogram of wheat. If we would save water in those places, if we would make the water use more efficient in all those red areas, we would be able to save a lot of water. We looked at this kind of maps for all crops, and if you reduce the water use for all crops to match the best 25% of production in the world, we would save about 40% of the current water use in agriculture. So there's a huge opportunity there. But we need to go beyond. It's not only about producing what we produce in a more efficient way, we should also look about the whole efficiency of our food consumption pattern. You see, if you look at the water footprint of different commodities in liter per kilocalorie, that the amount of water you need for livestock products is generally much bigger than for crop products. So for instance, if we consume beef, we require 20 times more water than if we eat nutritionally equivalent amount of crop products. So we need to be concerned with animal products, particularly because producing animal products is often, and particularly producing the animal feed, is often the largest water consumer in areas, and even in very water-scarce areas like in California, where animal feed is the #1 water user. Can you imagine? Currently, we have a 4 years drought already, headline news all the time in California. People have to cut water use at home. But rightly so, people start to question why then the primary user of the water, which is animal feed, still gets all the water. So this is something that should be on the agenda. If we take sustainability serious, we need to address the most sacred cow in our modern consumer society, which is meat consumption. If we would never shower anymore, rather dirty, huh? We would save 50 liters per day. If we wouldn't eat meat, which is not dirty, we would save 800 liters per day. We save 1,000 liters per day, but we replace by crop products about 200 liters per day, so we save 800 liters per day. So we need to think about our consumption patterns as well. Take me right, by the way, a shorter shower is okay, but not in order to save water, it's to save energy, because we like hot shower. It costs a lot of energy. So now I make a bridge also to my next topic, which is water energy. There's a huge concern here, because we are thinking in silos and we are working in silos. So what we see, the water sector is becoming more and more energy intensive, while at the same time the energy sector is becoming more and more water intensive. So there is something wrong here, because if we want to solve the energy problem and the water problem, of course we need to devise strategies that reduce our carbon footprint on the one hand and reduce the water footprint at the same time. So the water sector is becoming more energy intensive because of desalination, pumping water from deeper and deeper, getting the water from further away. And the energy sector is becoming more water intensive because of the shale oil and gas, the tar sands, which are all more water polluting, water intensive, but primarily biomass. Biomass is a very bad idea in order to get rid of fossil fuels, because biomass is requiring a lot of land and water, which we don't have. It will just come on top of the water scarcity we already have. Just let me give an example for biofuels. All the numbers are large, because we see 1,000 to 20,000 of liters of water are necessary to produce 1 liter of a biofuel. However, then sometimes it's even worse than other times. So sugar beet is relatively efficient, but then why we make rapeseed in Germany to make biodiesel? This is not very efficient. Here we see the problem currently we have. How are we going to move away from the fossil fuels? Are we going to the left in the graph, or are we going to the right? The left is hydropower, biofuel, firewood, very water intensive. The right is the only sustainable way. This is solar and wind energy. The water footprint is not fairly distributed either. We see in the US, we have a twice as big water footprint as the global average, while other countries have a much lower water footprint. So if we talk about reducing the water footprint of humanity, who is going to reduce most? The maximum sustainable water footprint is going down per capita because of the growing population. The US will have to reduce its water footprint per capita by 2/3. Well, a country like China, growing rapidly in the water footprint per capita because of the meat consumption that is increasing, should also reduce at some point of time. Well, Brazil is kind of in between. Germany, Netherlands, UK are more on the level between Brazil and China. We see that water is becoming more and more a global resource. And the green areas are the areas that exploit water to make water-intensive commodities for export, while the red countries, Europe, is heavily dependent on the import of water-intensive commodities. So we are reliant on water-intensive commodities from a lot of areas that are water scarce, which I just showed earlier. In the US, huge water scarcity. India, China, this will not continue. So if we think about our water footprint, we should understand that a large part of the water footprint is relying in non-sustainable areas, which is a certain risk. So we need to think about, let me show you a few of those countries where it's unsustainable water use related to the German consumption. We need to think about how we move to wiser water governance. Having water footprint caps per river basin, benchmarks by product so that we know what is reasonable, fair water footprint shares by consumer. Thank you so much. That was what I needed. That's what I needed. Let me finalize with a final remark. We need to take our responsibility as consumers, investors, governments, and also finally the politics and the government. If you want to know more, please have a read in my book. Thank you. This is even better. Thank you so much.